Okay, folks, we're going to continue in working problems. Let's look at this problem number 10 right here. Rewrite in terms of sine and cosine. This is really a difference identity for sine. That's how we're going to understand this problem. Now, we've done this a few times before, so we know this is going to be the sine of the first times the cosine of the second. Remember, this follows these signs, minus the cosine of the first times the sine of the second. Okay? Well, let's see. Now, remember our unit circles, so we got that 3/4 pi is over there. So this is going to be a negative radical 2 over 2. The sine of 3/4 is going to be a positive radical 2 over 2. Okay, let's copy this down. Minus cosine of x. Okay. Now, notice that this part's negative, and if we move that negative sign out to the front here, that's going to be negative 2. So we could factor out a negative radical 2 over 2, and what would we be left with? Sine of x plus cosine of x. That's how I would write it in a simplified form, but you could have just simplified the signs as well. Okay, keep that in mind. Now here's a problem, a little bit of a challenge here. Let me move this out of the way. Simplify each. Okay. If we think about this, this is just a cofunction identity. This is this business with the triangle, and there's an angle here, and then its complement. So the complement of secant is really cosecant of the angle. Whoops, that's cosecant of the angle. Now I'm done with that problem. But let's just say that you didn't know the identities that well. You could say that secant is really 1 over cosine of this angle, which is pi over 2 minus w. Now we could use the difference identity for cosine, so notice what that would be. That'd be 1 over what? The cosine of pi over 2 times the cosine of w, remember opposite signs, sine of pi over 2 and cosine of w. Well, let's see what happens right here. Actually, this is sine right here, right? Sine. Okay, what is cosine of pi over 2? Hey, that's 0. What is sine of pi over 2? That's 1. Let's rewrite this. 1 over 0 plus sine of w. Now, that is going to be 1 over sine, but everybody knows that's just equal to cosecant. So notice that it took us a long way to get this way, but if we just know the identities, it helps us out. That's true of a lot of areas in math and science. So it does, you got to be a good judge of how much time you're willing to put into the course. Hope that helps you out. Okay, now here's an interesting identity. Prove the identity. Now remember, we're trying to get one side to look like the other side. The question is which one's going to be the more complicated side? It would seem that this side would be the more complicated side, but if you notice, we probably could use a summation identity. So let's try that. Now we're going to have to go back, since we haven't really talked a lot about this. I'm just going to say a plus b. Okay. And this is equal to a fraction. The first part is tan of a plus tan of b, and the bottom is 1 minus their product, tan a, tan b. That's a lot of tanning lotion right there. Okay, now you could kind of see that we're going to get close to that if we follow this plan. So enough said. So we're going to start with tan of x plus pi over 4. Remember, that's 45 degrees, right? Tangent of 45 degrees is 1. Okay, now that is equal to what? Tan of x plus tangent of pi over 4 over 1 minus tan x times tangent of pi over 4. Okay, now we know that tangent of pi over 4 is just 1. Tangent of pi over 4 is 1. So we could rewrite that as tan x plus 1 over 1 minus, well, what's tan x times 1? Just tan x. Okay, now look at this right here. Is that what we're trying to find? Yes, okay. Now, I didn't do this exactly formal, but I did the important steps, and I think that you could follow that out. Okay, now notice, take a good look at this problem here, okay? What we need to realize is it kind of looks a little like the last one, but we seem to, the top here seems to be sum and difference identities for sine and cosine. So I just wonder if there's some trick to this. If we could move over here, we may be able to break that down. That's an idea. It's a good question. How are we going to approach this? Okay, now we're going to purposely make some mistakes here. Let's just say we wanted to use the plan we used last time. Now, if we were going to do this, wouldn't that top be sine of A plus B over cosine of A plus B? That would be tangent of A plus B, right? Over sine of A minus B, and over cosine of A minus B. Correct? Okay. Now that's not bad. Could we break that down further? In other words, hey, let's take the top part, okay, and rewrite that over here. So let me see. Let me do this. I have my big bar, and then I have a little bar at the top. So on the top's going to be, what is that? Sine of A cosine of B plus cosine of A sine of B. Makes sense? Okay. Now, if you notice here, seem to be having a little problem that doesn't exactly match up, does it? But since we already made a commitment here, let's just see what happens. Okay, well, what's the bottom going to be? The bottom is going to be cosine of A plus B. What is that? That's cosine of A cosine of B, right? Minus sine of A sine of B. Okay. Now, how about the bottom? The bottom would be what? Same thing as the top. Sine of A cosine of B, but this time minus what? Cosine of A sine of B. Okay, and again, this is all over cosine A cosine B plus sine A sine B. Okay, now if we look up here at the top again, notice we have sine A cosine A. How would we get that? How would we get that from this situation we're showing here? That's a very good question. Now, notice we've got so many factors here, and it'd be very hard to simplify this expression. So what we're going to do is we're going to say, maybe I made a mistake. maybe what we need to do is start with the left side first. Okay, this is why we have erasers. Okay, so let's see if that makes any sense. Okay, now I've been playing with this one for a little while here, and I'm not getting it very easily. So I'm going to go on to some other problems, come back to this one later. All right, so let's look at some questions related to the double angle. Let's pick another color here. If cosine of x is 2/3, and we're in quadrant 1, find the exact values for the following. All right, well, the first thing that I would do is I would draw a picture. The angle doesn't have to be perfect, okay? We're just going to call this angle x. It gives us a picture to orient our the relationships of the angle and the sides. Now, cosine is adjacent over hypotenuse. So this would be radical 5, correct? 9 minus 4. All right. Now, it's saying find all the following. Let's do the first one. Sine of 2x. This is actually a double angle identity. And how does it go? 2 sine x cosine x. Okay, now could I do that? Yeah. I know the sine of x. The sine of x is radical 5/3. Cosine x, they just gave it to me, it was 2/3. Don't forget you got a 2 out here in the front. So the sine of 2x is equal to 4 radical 5/9. Now, you could check this with your calculator, and how would you do it? Well, you could use the inverse cosine and find this angle measure right here. Let's just say it was 19 degrees. I'm not saying it is, okay? But to find sine of 2x, just find sine of 38 degrees, okay? And that should be the equivalent of the decimal part of your answer right here, okay? That's just, a little quick advice here. Now, how about cosine of 2x? There are a lot of ways to do that. Since you already have the cosine of the value, maybe it'd be a good idea to just use the identity, the double angle identity that just uses cosine. So again, I'm looking at my sheet. Cosine of 2x is the same thing as 2 cosine squared theta minus 1. Okay. Well, now 2 times, we already know the cosine is 2/3 squared minus 1. 2 times 4/9 minus 1, or 8/9 minus 1, which is, right, that's just negative 1/9. Okay, you could do that. Now, how about tangent of 2x? Here's where you're going to need a double angle identity for tangent. And that guy is this. Again, we're doing C right here, right? 2 tan theta over 1 minus tan squared theta. Okay, well, what is, well, actually we're doing with x here, right? X. Well, what is tangent? Tangent's radical 5/2. So this is going to be equivalent to 2 times radical 5/2 over 1 minus radical 5/2 squared. Okay, let's simplify that. Of course, the top's just going to be radical 5 over 1 minus, well, radical 5 squared is just 5/4. And let's see. That's just negative 1/4. That's negative 1/4 here. So it's going to be negative 4 radical 5. Negative 4 radical 5. Okay. All right, now just kind of think about it. If doubling that angle causes it to be minus, it must be in the second quadrant. That's something to think about. That's an example of working through those types of problems. Okay, now I really do like these problems right here because